Okay, let's look at infinite limits and vertical asymptotes. Alright, infinite limits. Here's the definition. Limit of f of x as x approaches a is equal to positive infinity or negative infinity. Right? If it's positive infinity, f of x increases without bound. If it's negative infinity, f of x decreases without bound as x approaches a. All right, so let's look at these examples. All right, so in order to evaluate this infinite limits, all you really have to do is kind of plug in and see what happens. Right, so x is approaching -3 from the left. So if you plug in -3 here, so you're going to get the -3 squared, so which is going to be +9. Right, so I'm going to go ahead and write +9. Right, then -3 plus 3, so you actually get 0 on the bottom. Right, but whenever you get a 0, you have to indicate which side you're approaching 0 from. Right, so in this case, x is approaching -3 from the left. So you can think of this as a slightly smaller than -3, so you can think of it as a -3.001. Right, so -3.001 plus 3 is going to be slightly negative, so I indicate that putting a negative sign here. Alright, so whenever you divide 9 by something very close to 0, the whole fraction is going to be a huge quantity, so I'm going to just indicate that. So this guy is going to get larger and larger by putting the infinity sign. Alright, then we just have to determine the sign. On top, 9 is a positive value, right? And the bottom is slightly negative. Positive divided by negative is negative, so you have a negative sign there, so it's going to negative infinity. All right, how about this one? So it's the same function, but the x approaches -3 from the right. Right, so the top is the same, -3 squared, so it's going to be 9. All right, and that's going to be still positive. Right, -3 plus 3 is again 0 on the bottom, right? But now x approaches -3 from the positive side, which means that it's slightly larger than -3. So you can think of it as a -2.999 or something like that, right? So -2.999 plus 3 is going to be slightly positive, right? So you have, right, 9 divided by 0 is going to get big, right? Positive divided by positive is going to be positive, right? So we have that. All right, then this is just a two-sided limit. Of course, these guys don't agree with each other, so the best you can do is say does not exist, right? Right, note that the limit of these guys, infinite limit, do not exist. This is a descriptive way of saying that we know that this limit does not exist because it blows down to negative infinity, right? So this guy, actually, the limit does not exist because it goes to negative infinity. And the same way here, this limit does not exist because it blows up to positive infinity, right? So, but try not to use does not exist for these first two, because we can say a little bit more than just does not exist. It actually goes to negative infinity, and this guy goes to positive infinity, right? But this two-sided limit, there's no way, this is the best we can do. So limit, they do not agree with each other. Two-sided limit just does not exist. So we have that. All right, And next topic is vertical asymptotes. All right, so here's kind of a precise definition. We already talked about vertical asymptotes. All right, so we say x of a is called a vertical asymptote of f of x if the limit as x approaches a from the left goes to either positive infinity or negative infinity, or x approaches a from the right goes to positive infinity or negative infinity. All right, so let's look at this following example. All right, so you have this rational function here. Right, we're going to go ahead and factor out the numerator and the denominator. All right, on top it's going to be x minus 1 times quantity x plus 2, I believe. Let's check. Negative 1 times positive 2 gives you negative 2. Negative 1 plus positive 2 gives you positive 1. Right, on the bottom you have x squared minus 1. So you can factor it out as quantity x minus 1 times quantity x plus 1. Right? So we have that. Then let's take the limit. All right, so this is going to be limit of this function as x approaches negative 1 from the right. All right, so we have that, but you can see that before we take the limit, we can cancel common factors out. So you have x minus 1 and x minus 1 is in common. Right, then we can just take the limit. So limit as x approaches, right, negative 1 from the right, right, so you have x plus 2 over x plus 1, right, so plug in negative 1. Negative 1 plus 2 is positive 1 on top, right, so negative 1 plus 1 is actually 0, right. Then since x approaches negative 1 from positive side, so this is going to be positive right here, right? So which means that here this is going to go to, of course, infinity, right? Positive divided by positive is going to be still positive, right? So you can see that this one-sided limit goes to positive infinity. It could have been negative infinity. Therefore, x equals negative 1 is a vertical asymptote. So here's the vertical asymptote we found. The first one is x equals negative 1, right? Because this guy blows up to positive infinity as x approaches negative 1. So that's why x equals negative 1 is a vertical asymptote. All right, how about this one? So if you take the limit as x approaches, you can do a positive from the right or from the left. Let's do a two-sided limit. So you have a limit as x approaches 1 and x plus 2 over x plus 1. Right, so x equals 1 is could be it's a good candidate as vertical asymptote, because if you plug in 1 in the bottom, it's going to actually make the denominator 0, right? But if you take the limit, you can see that this is going to actually go to 1 plus 2 is 3 over 2 plus 1, 1 plus 1 is 2. So it actually goes to 3/2, which is not equal to either positive or negative infinity, right? Which means that the x equals 1 is not a vertical asymptote, right? So therefore, only vertical asymptote that this guy has is x equals negative 1, right? And you can kind of see here's a graph of y equals f of x. And you can see that there's a vertical asymptote here at the negative 1. Oh, I didn't write here. Here, this is negative 1. It's kind of hard to see. All right, so this is a vertical asymptote here. right? But so this is x equals -1, right? But there is no vertical asymptote at the x equals 1. What it has is actually a missing point right there, right? Since 1 makes this denominator equal to 0, this rational function is not defined when x equals 1, but the function does not blows up, or the graph does not blow up or blow down at +1. So therefore, x equals 1 is not a vertical asymptote, right? That's it. I hope that this was clear.